Just a few preliminaries. Mark Byerly is going to force me to explain the tie. I actually am an implementer. I code, but not on the job. I code mostly in C++, some Java on the side, but don't tell my manager. So the tie is part of the lie. In case I forget to mention it at the end, I am finally entering the world, the blogosphere. I'm starting a blog, so if you want to follow me, the blog is called thoughtsonit-ted.blogspot.com. thoughtsonit-ted.blogspot.com. It says nothing there about Bank of America because Bank of America is a heavy user of social media analytics, and if they see my name and Bank of America on the web anywhere, I'll get a little email. So, but if you found Ted, you found me. And finally, Arvinder and I were comparing our little series of ribbons, and I was wondering, do I really get status as an expert speaker? But Arvinder's ribbons say he's a speaker expert, so he's going to let me know when I'm done whether or not I qualify. Okay, so we're going to take a little bit of a right turn from talking about data virtualization and talk about a related and as far as I'm concerned, an extremely important topic, and that is real-time data processing. We will come back to data virtualization by the end, and I'm not going to explain until the end where that title came from for the talk. But let me start by talking about the environment in which I live and work at Bank of America. Bank of America is just a long list of number ones, and of course the list changes a little bit with changing market conditions. These numbers are all as of the end of 2010. Many of them are still true. Number one globally in leveraged loans and mortgage-backed securities. Number one globally in asset-backed securities and syndicated loans. Number one in the U.S. in investment banking, and on it goes. I won't bore you with the numbers. But the point is, in financial services, Bank of America is, by many measures, the largest financial institution, and by other members, among the largest of financial institutions. Now, what that means is that we have tremendous scale. And talking about the 3 V's, we have a tremendous volume of data, tremendous volume of transactions. I just want to highlight a few here. 5,800 banking centers processing 0.8 billion or 800 million teller transactions a day. Well, that's about a year. That's about 2.2 million a day. 18,000 ATMs across the U.S., 1.2 billion transactions a year. That's 3.3 million a day. Our online website has 2.6 billion online sessions a year. That's 7.12 million a day. We, of course, are a heavy issuer of credit cards, and we process about 8 billion merchant transactions a year. That's about 2.2 million a day. So the scale is enormous. Obviously, at Bank of America, in many of our operations, there is no choice but to process data in real time. However, this crowd here, I suspect, is oriented or tilted towards analytics. And there is a tradition that we start our analytics at the end of the day, because we won't know everything we need to know about the day's business till 5 p.m. or 6 p.m., and that's when we should gear up our analytics. Well, my message here is that's not how we should think. We should think about processing data as soon as it changes. And so I'm here to evangelize, and let's see if I can convince you that this is true. So as I see it, there are 4 reasons why we should process data as soon as it changes. And the first is a value argument. If you think about the business value of data, it's actually the highest at the moment it's created, because it's created in order to serve a purpose, in order to support a business transaction, in order to execute a business transaction. Sometimes it's a byproduct of a business transaction. So that's why the data came into being, in order to do business. And the data is used then immediately in order to fulfill that transaction. And then probably at the end of the day, over the next few days, the data is used as part of operational reporting. And gradually it makes its way into the enterprise data warehouse, where it languishes a bit until those who are interested in doing analytics on the data begin to use that data that was originally created for transactional purposes. So you can say the value of the data has gotten higher at that point. When the analytic use is over with, after it's been looked at for a few days, weeks, maybe months, again, it goes into disuse, and the value to the business of having that data goes down. Eventually, the value actually becomes negative, because there is a cost to keeping the data. The obvious cost is the storage cost of the data, and I don't know about your companies, but it's actually even hard to count how much storage Bank of America has. We think it's around 48 petabytes, but we're not sure. And you just can't sustain storage growth indefinitely. At some point, you have to get rid of the data. It's the disk. The cost of the disk is not the problem. It's the cost of the space in the data center. The other issue, however, with keeping data for indefinite periods of time is legal liability. If you keep data related to a transaction beyond the statute of limitations, you can still be sued based on that data. And now, if you've kept data for 10 years and the statute of limitations said you were only responsible for that transaction for 5 years, you've extended your own liability just by not being careful about deleting your data. So the value of data can be negative at the end of its life. It's highest nearest the beginning of its life. So given that in general the value of data is highest immediately after it's created, therefore, if you delay processing it, if you allow the timeline to move to the right on that graph, the value of the data you're processing is lower. So it only makes sense that data should be moved, processed, and used absolutely as soon as possible after its creation. So that's the first reason, whether you're doing analytics or any other kind of data processing, you should process data as quickly as possible. The second reason is more of a cultural reason. Technology breeds impatience. You know, I don't know about you, but I'm a big fan of Amazon. I must live near an Amazon distribution center. I can order a book on Monday morning and have it on my doorstep on Tuesday afternoon. You know, all the brick and mortar bookstores are closing, and it's really because of Amazon and their competitors. Now, if I can get a book in less than 2 days, if I can walk into a cellular phone company store and in less than 2 hours walk out with a cell phone where I can call any phone number in the world in less than 2 hours. If in less than 2 minutes I can get onto my Comcast set-top box and order a movie and start watching it, and if in less than 2 seconds I can execute a trade online, why, as a technology executive, do I have to wait to see data that my own corporation already has? Because someone in analytics thought they'd start processing it at 6 p.m. Well, at 6 p.m. I'm going home for dinner. So we, technologists, have helped create a culture where we expect everything instantly, and we should expect everything instantly because the technology is capable of giving us that. So there's another reason to do things in real time. Here's a third reason, and hopefully this reason is diminishing, but I know it's not gone. What I call batch waterfalls. Many of you are familiar with the scenario where it's 6 p.m. Eastern Standard Time, and the business day is over, and so it's time to start up the overnight batch processing. And so that first job starts up at 6, and it begins to collect the data, and it does some preparation, and then it finishes, and the second job in the job stream picks up. And on this goes all night, and hopefully by 6 a.m., the last job finishes successfully. Well, if one of those jobs in what can be a chain of literally 100 jobs or more fails, and now you need operator intervention, and you've got to call a support person who might be in a different time zone, might be asleep, and fix that, you've got a very limited window of time to fix that failure. If that failure isn't fixed and the batch stream restarted quickly enough, that last batch job might not finish by 6 a.m. the next morning, and there will be a 24-hour delay in the availability of information about the previous business day. It gets worse if you've got a situation that's very common, such as a U.S.-centric company that's trying to be an active business partner in the Far East. And the Far East's business day is in the middle of the U.S. night, and if there's a batch waterfall failure, then let's say Japan's data doesn't get into that night's batch processing, and they're going to have a 2-day, a 48-hour delay in seeing the results of what they did on Monday visible to their management. It won't be visible on Tuesday. It won't be visible till Wednesday. So the batch waterfall just really is a reason. You don't want to have a batch waterfall. You don't want to have a situation where you delay everything normally by 24 hours and people live with that, but under failure conditions can be 48 hours or worse. And very strongly related to that, and I apologize, the typography got a little messed up here, but very strongly related to that is the fact that the whole concept of overnight is really gone. If you're, even if you're a US-centric business and you support internet customers, overnight has no meaning anymore. In the lower right here, the New York, USA business day, each of these bars represents the business day, is 9 a.m. to 5 p.m. Eastern Time. The rest of that horizontal bar is night, the window for batch processing. And gee, that looks luxurious. Look at how much time you have to do your overnight processing of analytics. But look at Japan in the upper left. It's smack dab in the middle of the U.S. night. So do you really want to tell your Japanese customers in the middle of their day, I'm sorry, we can't do business with you now, we're doing our overnight batch processing? Or we'll do business with you, but please wait 2 days for the results to show up in your account. These answers just aren't acceptable anymore. It just doesn't work. So to summarize, here are 4 reasons why we should be doing our analytics in real time. First of all, the value of data is highest immediately after it is created. So the sooner you can process it, the sooner you can deliver that value. Secondly, our culture, our technology culture, has bred impatience, and it's appropriate. Technology can deliver things in real time. People should be able to accept it. People should be able to expect it. Thirdly, batch waterfalls are something to be avoided. We don't want cascading delays that can produce 24 to 48-hour delays in our results. And finally, overnight doesn't really mean anything anymore. So here are 4 good reasons why we should be processing in real time. But there are barriers, as there are with anything. So what are the barriers? Why aren't we changing all our systems over away from batch processing to real-time processing? Well, there are a number of barriers. I'm just going to talk about 3 of them. The first one, as I see it, and the most significant, is a lack of experience developing and operating real-time systems. The second reason, lack of executive support for doing things in real time. And the third reason, a myth that it's more expensive to do things in real time than in batch. So let's take these one at a time. I believe the number one barrier to achieving real-time processing, the number one reason why it's not done more widely, is simply because our technology staffs, and even more importantly, our technology management, does not have experience developing, implementing, and operating real-time systems. And I'm afraid to say this is probably to some extent a generational issue. But it can also be a cultural issue. We've always done it that way. We have lots of people very experienced in thinking about problems in a batch way, what I call the batch mentality, which is at a certain time on the clock, you start up, you gather all your data that you've been accumulating throughout the day, you process it, you shut down. and you do that again tomorrow. That's the batch mentality. It's very difficult to change someone's thinking away from the batch mentality. Well, how do you want to change their thinking? You want to change them to think in terms of a real-time mentality, which is not to wait for the hands on the clock to reach a certain point, but instead to wait for that simple event of data that has changed. A new transaction has been executed, the status of a customer record has changed. Any time when data has changed, it's now time to start processing. And so you have the same lather, rinse, repeat cycle, but the difference is you start it as soon as one piece of data changes. And you start transmitting that data to others who will use it. You start processing that data where the result of the process requires that data. You only accumulate data if you need other data to go along with it in order to do the processing. And there's a fascinating set of statistical processes that we think of, well, how can you compute the average daily balance before the day is over? Actually, you can. It's not complete until the day is over. But if you compute the average daily balance as the day progresses, then the instant the day is over, you have the average daily balance. You don't have to start up a giant batch process to compute 2 million average daily balances. They're just available at 12:01 a.m. And these kind of techniques can really help you deliver that business value as soon as possible after the data's changed. So you repeat this cycle not once a day, not once an hour, but all day long, every time a piece of data changes. This is the real-time mentality. The batch mentality says, I'm going to start when the time reaches a certain point. The real-time mentality says, every time a piece of data changes, I'm going to process that change. And it does take experience, just as we have skilled and experienced staffs who know how to implement batch systems effectively. We need to have skilled and experienced staffs who know how to implement real-time systems effectively. There are techniques, there are pitfalls. You have to learn how to build in throttling mechanisms and restart mechanisms and queues and all sorts of things. But these are all achievable skills, and if you have difficulty building them into current staff, I would say to get this done, you might want to hire just a few people from outside to inject that real-time thinking into your group. Now, another barrier to achieving real-time processing is a lack of executive support. Executives, and I'm talking, C-level executives, they don't spend much time thinking about batch versus real-time. But they should realize that every business is a real-time business, and I'll talk about that more on the next slide. And if they realize that they're in a real-time business, and then somebody tells them, oh, by the way, we only process our data once a day, they're going to begin to get a fire in their belly and a passion for real-time data processing and be able to drive the cultural change that's needed and the skill set change that's needed top down. So you need to talk to your executives about the need for real-time processing, get their buy-in, and get the message out. And it's really about culture change and about shifting the cultural values of the organization to let people know that, batch systems are great, but real-time systems have higher value. That's what our CIO said. That's what our CFO said. And that's going to really change how your technical staff with the batch mentality are thinking. They're going to be thinking, well, if a high-level, highly placed executive thinks this is important, I better start researching how to do real-time processing instead of batch. So how real-time is your business? Well, do you do everything at 5 p.m.? Do you sit with your hands folded at your desk until 5 o'clock and then you pick up the pen, pick up the phone, start doing mails? Of course not. Do your customers do that? Of course not. Do you ignore what's going on in your business until 9 a.m. the next morning when the electronic equivalent of the paper report gets put on your desk and you log in and see, well, what happened yesterday? I hope not, for the sake of your business. Business transactions, all business transactions by definition, take place in real time throughout the day. They're not scheduled. Neither should our processing. It should be event-driven. Okay, third and final barrier that I will dig into about what keeps us from achieving real-time data processing, and that is a strong belief in a myth, that myth being that real-time processing is more expensive than batch processing, and it's a deep myth, so I'm going to spend a little bit of time on this one. This myth says two things. First of all, it says, well, it just is harder to develop real-time systems than it is to develop batch systems. So the extra cost isn't justified. Secondly, once we've got that real-time system in operation, it's going to require more CPU, more memory, more disk, more network than the equivalent batch system. Both assertions are not true, and I'll tell you why. First of all, if you are in an organization that has only ever implemented batch systems, the first time you do a real-time system is going to cost you more than the equivalent batch system simply because of the learning curve. Let's not hide the fact. Developing the real-time mentality requires a shift. It requires learning. It requires testing your skills, making some mistakes. You'll need to do those pilot systems we all know are very important when we're venturing into new waters. So that first real-time system will cost you more to develop than the equivalent batch system. But once you've got the real-time mentality and a skill set built into your staff, given a problem, a business problem to solve, and the option to produce a batch solution or produce a real-time solution, the cost is about the same. There's virtually no difference in the cost to implement a batch system versus a real-time system, and I'm speaking from someone, as someone who's done both. So, if that's the case, then if that's the case, there's really no reason to hang on to this belief that real-time systems cost more. That'll only be true once on your first one. So that's the first half of the myth. The second half of the myth is that it just is more expensive to process data as it changes in real time. Well, think about the load on systems that batch processing puts versus the load that real-time systems put. Batch processing concentrates all the load in that overnight batch window, which, by the way, doesn't really exist anymore. Overnight doesn't exist anymore. So you need more resources standing by to do your processing overnight than you would if you were just doing the processing as the data changed. Further, once you're finished your batch processing, you've got that excess capacity just sitting idle throughout the business day. Now, I call this a slight oversimplification because if your business is concentrated in a single region and that's where you do your batch processing as well, then you can actually use that excess batch capacity to do your daily business processing. But if you're a global 24/7 operation, that argument doesn't apply, and you're really increasing your need for processing power by forcing all your batch processing to be done in a limited time window, and you're wasting processing power during the day. So it really does not cost more in terms of network, CPU, all the rest, to process data as it changes. And then if you shift from looking at just the cost side of the equation to the value side of the equation, remember again, the value of data is highest nearest its point of creation. And in the batch world, data is nice and fresh and tidy in the morning at 9 a.m. when you get to your desk. By the end of the day, it's stale. Whereas with real-time data processing, the data is always fresh, always available. You don't have to wait an extra day to see the results. It's just always current. So the value story for real-time processing is a much better story than for batch. Now let's bring this back to the topic of the day, which is data virtualization. Data virtualization actually fits very well into a strategy for real-time data processing. It can make real-time, the cost of implementing a real-time solution much more reasonable than if you didn't have a virtualization tool. So let's look at the before picture first, the orange oblong rectangle shows you the traditional batch cascade, and the traditional approach is that at 6 p.m. after the close of business, assuming your business ever closes, you have some combination of techniques, often using ETL and other tools, that pull all the data in from the various places where it's located and accumulate it. You typically have hand-coded data integration where you've carefully written all the statements that often in ETL or in a stored procedure or somewhere else that will bring the data together so that you can begin that long cascade of batch processing that's going to run overnight, so that by the next morning you can update your warehouse, do a full update with the previous day's results to be available in the warehouse the next day. That's the before picture. Now, if we think about this not in terms of waiting until the clock reaches a certain time and then processing everything at once, but process data as it changes, and if we use a data virtualization tool such as composites, in the picture changes significantly. The yellow lightning bolts represent events that can trigger processing. The event could be a trigger from a DBMS, it could be a web service call, could be a few other mechanisms. Composite Server can take in any of these events to trigger processing. And then the data integration, instead of being a pull of large amounts of data all at one time on the clock, you just pull just the data that changed and just the data you need to support processing that data, much smaller quantity of data. And you don't do this for 12 hours overnight. You do this just as quickly as you can as soon as the data has changed. And T+2 could literally be 2 minutes later, 2 seconds later, 2 milliseconds later, depending on the processing scenario. And instead of updating a whole day's worth of data in the warehouse, you just update what changed. So the update at the receiving end is much more lightweight. You're not having to update a whole day's worth of data, but just the data that changed. Let's take a closer look at how you could structure the data integration inside the composite server. First of all, naturally, you're going to virtualize all your data sources. They're going to appear to be tables, whether they are in fact tables in source DBMSs or whether they're files or web service sources. They'll all look like tables. You can build your virtual view that does the data integration, and instead of writing procedural code in ETL or in a stored procedure, you would write a virtual view. You can add procedural code in there where that matters. You can cache the result of this. You can even cache the sources if you wish. And you can trigger it all. You can start all this processing as soon as the data changes based on a trigger in the source. And you can pass that trigger along so that once Composite's done its job of data integration, it can trigger the next step in your process. Now, that was just a very brief look. There are many ways of doing it, and I'm not addressing a single use case here, so hopefully you can use your imagination and adapt this to your own situation. But the point is, you can really leverage a data virtualization tool to achieve real-time processing. Many advantages to data virtualization, as I know many of you know. The result of your integrated data doesn't look like a file, doesn't look like the output of an ETL tool. It looks like a local database. So it's ideally suited for applications that expect to be getting their data from a relational database. Messages and triggers can be used to drive the processing so that you can start the processing as soon as there's an event where data changed. And of course, the virtualization tool is hiding the differences between the sources. So even though you might be getting some of your data in real time from an IBM DB2 database, an Oracle database, a Sybase database, a flat file, a web service, you can configure Composite to make it all look like a set of tables and get the uniformity you need. You can build in data conformance into the virtual views so that you eliminate the differences between reference data sets. And it becomes practical to do what used to be the DBA's nightmare, which is to join across the network. In fact, I find that as some of the most special of the special magic that Composite provides. I know how many times DBAs looked at me in horror when I said I wanted to join across the network, and I was forced to, code something to physicalize the data before I did the join. And now with Composite, you don't have to do that because Composite's optimizer will figure out how to join across the network in a supportable and performant manner. And you can even use a cache to preload the result or even preload the sources to make that even more practical. And the great thing about a cache, of course, is you don't need a DBA to manage your cache. It's just there. So this has been a very broad brush, high-level talk, but what I'm really on an evangelical mission here to convince you that it's 2011, it's the 21st century. A 2 gigahertz processor is standard issue. That means 1/2 of a billionth of a second is the clock speed of the processor. It can add two numbers in 1/2 of a billionth of a second, and we're going to wait until 6 p.m. to leverage that power. It just doesn't make sense. We really need new thinking. So why did I do this talk? Well, Bob Reary from Composite got an email from me, and he saw the byline in my email. Every email I send has this at the bottom: real time is the rule, batch is the exception. And so what do I really mean by that? And I think you're getting the sense of what I really mean by that. If you accept the reality that once you're past the learning curve, the cost to implement a real-time system and the cost to implement a batch system are actually the same, and if you realize that real-time systems deliver more value than batch systems because they're delivering that data sooner when it has more value, and they're evening out the load on your processors and network, then why would you ever build a batch system? Now, in self-defense, because I know hands are going to go up all over the place, I did say batch is the exception. There are some cases where you want to do some things in batch, but they should be really the exceptional cases. In other words, you should start out of the gate with the real-time mentality. We're going to do this in real time because that's the way we do everything. And then if you find a case where you have to time something because some event happens based on the clock as opposed to data changes in the world, it's only then that you say, okay, well, I guess we can't do this in real time. We'll have to do it in batch. And you heave a sigh and you go develop that little part of your system in batch. But the default conclusion should be that every system should be real time.